For part E, we have the net force equals mass times acceleration. For the forces acting, we would put F of x minus Fg of x minus F of friction equals mass times acceleration. F of x is F cosine theta minus mg sine theta minus mu of mg cosine theta plus F of sine theta, which would equal mass times acceleration. We could do F cosine theta minus mg sine theta minus mu mg cosine theta minus mu F sine theta equals mass times acceleration. Do F of cosine theta minus mu of sine theta equals m times a plus g sine theta plus mu of cosine theta, because we just moved it over, and then we would do F equals m times a plus g sine theta plus mu cosine theta over cosine theta minus mu sine theta. F equals m2 is 0.5 plus 9.8 sine of 20. This plus our mu 0.33 g 9.8 cosine of theta, which is 20, over cosine theta, which is 20, minus mu 0.33 sine of 30, which would give us a value of F equals 16.67 m. That would be our F for part E. And then part E, for part F, if an additional second block of mass 4m is now placed in contact with block M, derive an expression for the magnitude of the force F required to keep the system motionless. Okay, so for this, we would again do the net force equal to mass times acceleration, F of x minus Fg of x, this time of a plus b minus F of a plus b, and so just a or b would equal 0. F of x is F cosine theta minus minus m of mass of a plus b times g times sine theta minus mu of F of n of a plus b would equal 0. And then our Fn of a plus b minus F of y minus Fgy of a plus b equals 0. We get Fn of a plus b alone. It equals Fy plus Fgy of a plus b. Then we get it to equal F sine theta plus m a plus b g cosine theta would equal F sine theta plus m would be m plus 4m, which is 5m g cosine theta. That would be our simplified value of Fm plus AB, and then from there we can do F cosine theta minus 5mg sine theta, put it back in, minus mu F sine theta minus mu 5mg cosine theta, which would equal 0. And then F cosine theta minus mu F sine theta equals 5mg sine theta plus mu fmg cosine theta. And this one, we have f cosine theta minus mu sine theta would equal this sine theta plus mu g cosine theta. Then if we divide, you just get f equals 5m g of sine theta plus mu of cosine theta over cosine theta minus mu of sine theta. And then that was part F. Part G says if m is 2, theta is 20, mu is 0.33, calculate the force F required to accelerate the block up the ramp at a constant rate of 0.5, being part G. You can do G, which is the net force equals mass times acceleration. You can do f of x minus f g of x of a plus b minus f of a plus b equals m of a plus b a. Then you do f cosine theta minus m of a plus b g sine theta minus mu f of n a plus b, which is f mass of a plus b times a. Do f cosine theta minus 5m g sine theta minus mu f of sine theta plus 5m g cosine theta would equal 5 mass times acceleration. And then for the f cosine theta minus mu theta equals 5m a plus g sine theta cosine theta. Then you just divide it to get f alone. 5m plus g sine theta plus mg cosine theta over cosine theta minus mu of sine theta. And then you would plug in the values. You would get f to equal 83.34m. And part H is to calculate the magnitude of the contact force between m and 4m. In order to do that, we would again do the net force equals mass times acceleration. Net force would be f of a, b, minus f g of x, b, minus f of friction of b would equal m, b, times a, mass of b times a. So force of a, b, minus 4m times g times sine theta minus mu f of n times g equals 4ma. You have f n b minus f g y equals 0 and b equals 4mg cosine theta. From there you can do f of a b minus 4mg sine theta minus mu 4mg cosine theta equals 4ma. Then we can add everything over to the other side. you get F equals 4 A plus G sine theta plus mu cosine theta. You plug in all the values, you get F A B to equal 55.13 newtons. Absolute value. Because it would be the contact force on both sides. And then part I, a physics student claims that switching the order of the blocks as shown below does not affect the magnitude of the contact force between the blocks because the total mass of the system remains unchanged. Do you agree or disagree? For this, I think it would change, because if we were to change the order of the blocks, we would be using m instead of 4m in our formula for F equals 4ma plus g sine theta, which means our contact force would decrease. So I disagree that it would stay the same.